So in the last class, up to which slide I have explained?
So up to previous slide. So we will start from here. Reliability.
Okay. So first of all, the designer generally designs a product with the aim of highest reliability with minimum cost in minimum time. Three things: highest reliability into the product with minimum cost and also minimum time. Challenge for the designer as because these three parameters are conflicting to each other. If you try to increase the reliability in the product, generally it will enhance the cost. And at the same time, the time of production also may be increased due to higher reliability. Therefore, it is a challenge to the designer to design in such a way so that the optimum value of the reliability, cost, and time are chosen by the designer, isn't?
Yes,
Hello.
sir.
So first of all, we have to understand what is the reliability of a product or how it is measured. Actually, reliability is a probabilistic parameter because even after conscious design, there will be a lot of uncertainties and uncontrolled feature in real practices. Therefore, we can only ensure or rather can confirm that probability of something can be within this range. Confirmation is really difficult. So first of all, we have to understand the definition of reliability. Reliability is the probability that a machine or a component which we are going to design will perform the specified task under the given specified conditions for a specified life. So there are three red colored phrases in the definition. Specified task, every product are specified by certain responsibility, certain function, certain service. Those are the specified tasks. And of course, the environment or the condition under which the product is to be operated, it is also specified. And life of the product is also to be specified. Specified life may be infinite, still it is specified, whether it is finite or infinite. If finite, what is the quantitative value of that finite? And reliability is the measure, which is measured by probability theory, that the machine will ensure the specified task under specified condition for specified life. Specified task, the load bearing capacity in terms of force, torque, or some flow capability, some motion capability as specified for the product. Specified conditions are guided by environment, material, space, weight, available resources, etc., etc. And life may be finite and infinite. Product cost and time always are to be as minimum as possible for competitiveness. Here you can include time is also to be minimized as far as possible. And as because this reliability and cost or reliability and time are conflicting or opposing each other, therefore designer has to design with huge consciousness and considerations.
স্যার প্রোডাক্ট টাইমটা কি, মানে কতক্ষণ লাগছে বানাতে?
হ্যাঁ, তুমি ডিজাইন থেকে, ইনফ্যাক্ট এক্ষেত্রে টোটাল টাইমটাকে ধরা হয় ডিজাইন কনসেপচুয়েট করা থেকে শুরু করে প্রোডাক্টটাকে মার্কেটিং করা। এই টোটাল টাইমটাও একটা ইম্পর্টেন্ট ফ্যাক্টর, আদারওয়াইজ ইউ ক্যানট কম্পিট ইন দ্য মার্কেট। অথবা তোমার কাস্টমারের টাইম ডেলিভারি তুমি মেনটেন করতে পারবে। ইজ ইট অ্যাকসেপ্টেড?
ওকে স্যার।
ফার্স্ট হচ্ছে স্ট্রেংথ। আমরা যে what the different design considerations we have discussed, the most important thing is the strength of the product. The product must not fail. As we are interested in the mechanical component design, therefore here strength is the primary concern. That material should not fail under the given service condition. Strength is to be ensured. You have to select dimension, material, etc., etc., in such a manner that strength is ensured. Suppose load. One of the strength is determined by the load. What is the load bearing capacity? Under the given load, whether the material will fail or it can sustain the load, to understand or to predict or to assess, we have to know the material behavior under the given load. The material behavior under the given load depends on the magnitude of the load. At the same time, it depends on the nature of the load. The designer should be aware of it. That material behavior under static load, under dynamic load, or under fluctuating load are different in nature. Whatever may be the quantity of load, material behavior, failure mechanism depends upon the nature of the load, rate of loading, whether it is static, whether it is dynamic, or it is fluctuating. Secondly, strength of the component also depends on the environment. Different environmental aspects like temperature, presence of corrosive media, or radiation, etc., etc. There are so many environmental aspects which determine the strength of the component. Only by determining the dimension and material, you cannot ensure the strength. In which environment it will be applied, this knowledge has a bearing on your design. Here I am trying to discuss what are the different considerations, what designer has to consider while designing. So here environment is an important factor to be considered while strength is concerned. Regarding strength, material is another aspect because failure mechanism depends on the material. Material can fail in ductile manner, material can fail in brittle manner. And depending on the load, failure mechanism is also may be different. Under tensile loading, a kind of failure. Under fatigue loading, another kind of failure. Fracture is a different failure mechanism. Creep is a different failure mechanism. Failure against impact load is a different failure mechanism. So the nature of the material and the failure mechanism expected for the material is an important consideration for the designer. Have you understood the points?
Yes, sir.
Yes, sir.
Yes, sir.
Here I am trying to convey that what kind of knowledge a designer requires for appropriate or acceptable design. While strength is concerned, you have to know the nature of the load, nature of the environment, nature of the material, nature of the failure mechanism, etc., and etc. Stiffness is another property of the component. it is the resistance against deformation or deflection. I have discussed yesterday, or rather last class, that strength may be sufficient, but stiffness may not be sufficient. Stiffness may not be as per requirement. Strength means resistance against failure, but stiffness means resistance against deformation. And sometimes excess deformation can be the cause of failure. In that case, strength is defined in terms of stiffness. Stiffness is to be sufficient to avoid the failure. So therefore, designer has to know for a given system what are the parameters contributing to stiffness, how stiffness will be evaluated. And he has to design in such a manner so that permissible deformation should not be exceeded by the component under the given service load. Accordingly, he has to take decision. Decision regarding material, decision regarding dimension, etc. and etc. Another important consideration is life. From the specification of the product, regarding life, there should be some indication. Life means sometimes it may happen that the product or the component will not rupture, component will not fracture, but the services or the operational specification given for the product is not satisfied. Then also it is the failure. And whenever it is failure, then it is the life of the, up to the failure point, it is the life of the product. So for life, you have to know how you are defining the life. How? Whether failure is caused by the failure to meet the operational specification or the material failure. It may be failure due to operational specification is not meeting or failure due to material rupture or etc. When it is material failure, then modes of failure or mechanism of failure are important. How material can fail? Suppose a material or a component exceeds the yield point limit under the service load. So plastic deformation will start. If in a system it is happened that due to the load, material undergoes, component undergoes plastic deformation, you can assume it to be a failure. In most of the cases for mechanical member, this point is assumed to be a failure exceeding the elastic point, because at case the deformation occurred will remain as permanent deformation, which is not acceptable. So exceeding the yield point, exceeding the elastic limit can be treated as failure. In some cases, you may not be worried for exceeding the elastic limit. You can allow plastic deformation, but at certain point of plastic deflection, plastic deformation, it may rupture, it may collapse. So their plastic collapse will be the failure point, failure cause. Similarly, in some cases, material failure may be identified as failure due to fracture, total separation of the surface due to crack propagation. That will be the failure. When loads are fluctuating in nature, oscillating in nature, periodic in nature, in that case, the tiny cracks, small cracks present in the material may grow until the material is ruptured, and this failure due to progressive crack growth within the material is known as fatigue failure. Similarly, creep failure is there, I have explained, due to huge strain at high temperature at a constant load may cause the failure, which is called as creep failure. There are failure due to wear and tear, loss of material due to rubbing, or loss of material due to chemical action, which is known as corrosion. So material failure, while designing the component, the designer should have sufficient knowledge on these failure mechanisms, because until you can identify the exact failure nature or mechanism, you cannot identify the failure load. Depending on the different failure mechanism, different critical load will be identified. If you can identify the real exact failure to be occurred by the material, then only you can assess the real exact critical capacity, and then only you can design the product against the failure properly. So knowing or knowledge regarding expected failure mechanism in the material is an important input to designer. And designer has to consider all these factors. Do you agree or not?
Yes, sir.
এই অবধি কারোর কোয়েশ্চেন আছে কোনো? হ্যালো,
ক্রিপটা একবার বলবেন? ক্রিপটা
creep is a failure mechanism when material is operated at very high temperature. Then it is observed that even the load is remaining fixed on the member. Strain is not remaining fixed. Strain is continuously increasing. At high temperature inside the material, different phenomena starts to occur. Different microscopical or interatomic phenomena starts to occur at high temperature, which can create strain to be increased without any additional load. Strain will be continued, keeping the stress or load fixed. This phenomena is known as creep. And due to extra or excess straining in the member, material can fail, though the stress is at very low level. But huge strain in the material will not fail, and it occurs generally at high temperature. This failure is known as creep failure.
ক্লিয়ার স্যার। না স্যার, ক্লিয়ার স্যার।
Another part is aesthetics. Technical quality regarding strength, stiffness, life, etc., are mandatory specifications to be satisfied by the designer. But those are not the exhaustive considerations. Lot of products are there where aesthetics of the product or aesthetic feature of the product ultimately will dictate to assess the quality of the product. The quality of the product is assessed through the aesthetic feature of the product. Suppose when you are going to buy a refrigerator, domestic refrigerator or television, somebody are interested in the technical quality of the feature. They try to assess what are the technical parameters. But in most of the cases, when these technical features are more or less same from product to product, you are biased on aesthetic part of the product. How it looks like, what is the appearance, isn't? Hello? Hello?
Yes, sir.
Yes, sir.
So designers should have an attempt to improve the aesthetic feature of the product. He or she should try. Suppose chromium plating over the automobile component. it simultaneously improve the technical quality against corrosion, but at the same time it will add to the appearance, aesthetic part, isn't it? Or aerodynamic shape of a car with certain curvature. Because of this curvature, the appearance of the car also improved, but at the same time it will reduce the aerodynamic drag against the car. So there are aesthetic features which can be improved, simultaneously improving the technical quality. So those are always to be followed by the designer. Those are to be included into the product, as because it enhances the technical quality and aesthetic quality both. You agree or not?
Yes, sir.
Yes, sir.
What are the details of aesthetic part? Look, the material and surface finish. The surface finish or quality of the surface, the roughness of the surface, contributes a lot into the aesthetic feature. So designers should consider those materials which can be finished or machined up to highest quality of surface roughness. Those will be preferred. Or sometimes by painting, by anodizing, by electroplating, this feature should have to be improved if possible. Like brass and bronze material, these two materials gives better appearance regarding surface finish compared to steel or other products. So for improving the aesthetic part or aesthetic feature, sometimes designer may have preference over these kind of materials if technical quality is not going to be sacrificed. So designer should have consideration regarding aesthetic part, and while considering the aesthetic part, material and surface finish is one factor. Another factor is form or shape of the product. If designer have different options regarding shape, what shape he or she should select for a product. Different kinds of shapes are possible here. Some of kinds are given here. Step, sculpture, streamline, shear, taper. From the shape, it is transparent or it is obvious how it looks like. Suppose streamline shape. Streamline shapes are preferred for moving object. For moving object. If the object is a mobile or moving one, then sculpture and streamline forms are suitable. Rather, step and shear forms are suitable for stationary product, because streamline product will help you to reduce the hydrodynamic drag, and at the same time this contributes to the appearance for moving object. Now we come into ergonomic consideration. I have discussed what is meant by ergonomic. It is the considering related to the anatomical, physiological and psychological comfort of the user. When a designer designs a product, he has to keep in mind so that user can feel comfort anatomically, physiologically, psychologically. There are certain features of the product which gives physiological comfort to the user. There are certain features which gives psychological comfort to the feature. And some features are there which adds anatomical feature to the user. And designer has to maintain these features into the product so that user can exploit the benefit of anatomical, physiological, and psychological comfort from the product. What are the different area related to this ergonomic consideration? Communication. During the operation, user has to communicate with the machine. He has to operate separate button. He has to record different values of the parameter from the display unit. So there are a lot of communication issues between the user and machine, and how this component or product should be so that user can feel anatomically, psychologically, or physiologically comfortable. Working environment is another issue. The lighting, noise, temperature, air condition, circulation. These are the area where designer has to put importance. Another important issue is manufacturing aspect of design. Manufacturing aspect of design and assembly aspect of design. Design should ensure that assembly procedure will not be difficult. And if you have to make assembly easy, you have to take appropriate decision during the design period. Otherwise, you cannot ensure the assembly process easy. Similarly, there are certain manufacturing considerations that how easily it can be manufactured, how cheap or cost of production can be reduced by reducing the manufacturing cost, how it can be designed that during the manufacturing minimum damage will occur, minimum effect on the property of the component will be there by manufacturing. So there are a lot of issues regarding manufacturing and regarding assembly which are to be considered, and if possible are to be taken into consideration for the design. These considerations are called manufacturing and assembly considerations in design, and when design is done or when design fulfills these criteria, then it is called design for manufacturing and assembly. Design for manufacturing and assembly means the designer have considered several features regarding manufacturing and assembly. And there are a lot of benefits, because if you consider the assembly procedure at priori and took necessary decision during the design period, your assembly cost will be reduced, your assembly time will be reduced, your assembly will be user friendly. Similarly, you can reduce the damage on the product due to manufacturing by taking considerations of manufacturing aspect. You can make the product cheaper by reducing the manufacturing cost. What I am trying to say, that there are a lot of issues regarding manufacturing and regarding assembly, what or which designers have to consider during design. Do you agree with me or not?
Yes, sir.
These are the advantage. Now, design for assembly and DFA guideline. Some routine guidelines are there. Some routine guidelines are there for the designer regarding assembly point of view. Reduce the part counts. Number of parts in an integrated machine should have to be as minimum as possible. It adds, or it is advantageous to handle the machine, to maintenance cost will be low, assembly procedure will be easier if number of counts are lower. If number of counts or parts are huge, assembly becomes difficult. Cost of maintenance will be difficult because probability of failure of a part will be more if number of parts are more, isn't?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Use modular design. Suppose there are 1,000 parts in an automobile car. We can make 1,000 different parts and can assemble them. But if it is possible, we can subgroup these 1,000 parts into 10 groups. And how the group will be formed? 10 members in a group, or rather 12 members in a group out of this 1,000 can be grouped into a single block. First, we will sub-assembly this block by attaching these 12 or 15 or 20 members. And now in this way, we will develop 30 or 50 blocks consisting of 10 to 12 parts. Now these blocks will be assembled to form the complete product. This is called modular design. Have you understood what is meant by modular design?
Yes, sir.
স্যার একবার বলবেন স্যার
Suppose you have 1,000 parts in a machine. How can you assemble this product? You can add every 1,000, each item of these 1,000 items individually. And these 1,000 items are gradually integrated and forming a machine. Or you can conceptuate the configuration of the machine in such a way that the number of parts will be 1,000. But out of these 1,000 parts, you can subgroup. You can make subgroups, 20 subgroups. And in each subgroups, 40 to 60 members will be integrated. Now, how you will assemble? You first make the subgroups, the module. 20 modules will be first developed by connecting appropriate member within it. Now you have 20 blocks, 20 modules, 20 subgroups. Now you add or connect these 20 blocks or 20 subgroups to form the complete product.
ওকে স্যার আন্ডারস্টুড
This is called modular form of design. Modular forms are advantageous regarding assembly, maintenance, replacement, etc. তোমরা যদি কোনো কম্পিউটার সার্কিট দেখো, দেখো ওখানে বোর্ড ফর্মে করা আছে, তাই না? ডিফারেন্ট বোর্ডস আছে।
ইয়েস
হ্যাঁ স্যার।
আছে না? মানে পুরো যে আইসি বা চিপ গুলো লাগানো আছে, পুরো একটা সার্কিটের মানে একটা প্লেটের উপর র্যান্ডামলি লাগানো নেই, কতগুলো বোর্ডে ভাগ করে নিয়ে এবার 10টা বোর্ড অ্যাসেম্বল করা আছে না?
Yes, sir.
এটা হচ্ছে মডিউলার ফর্ম। তোমার মানে যখন চেক করবে একটা বোর্ড, ইফ ওয়ান বোর্ড ইজ আইডেন্টিফাইড টু বি ডিফেক্টিভ, if one board is identified to be defective, then they can replace the board instead of searching in the random integration. Board replacement করে দেন না এখন, দেখবে টিভিতে হোক, কম্পিউটারে হোক। সিমিলারলি মেশিন পার্টস এর ক্ষেত্রে এই ব্লক ফর্মটা, মডিউলার ফর্মটা ভাবতে হবে। বুঝতে পেরেছো কি সকলে?
Yes, sir.
Now assemble in the open. Parts should be joined in such a way that it can be assembled in open space as far as possible. Optimize part handling. We have to design the block or modular in such a way that part handling becomes minimum. Because when we are subgrouping 1,000 parts, number of possible ways are there. How you will define the block. Objective will be to minimize the part handling. Is it clear or not? Hello?
Yes, sir.
Do not fight against gravity. দুটো প্লেটকে জয়েন করছো, now you join these with screw or bolt, etc., etc. You should provide attaching the bolt from the top side, then it will not fall under gravity. But if you attach the bolt from the bottom side, then if sufficient threaded connection is not there, then it can fall under gravity, is it?
Yes, sir.
So while designing, where we will put the hole, where we will put the attachment, etc., etc., we have to avoid fighting against gravity. Is it clear?
Yes, sir.
We have to select the part, or rather we have to design the part in such a manner that which part is to be integrated with which part can be identified easily. And that can be done by introducing symmetry in the product shape. Because of the symmetry, you can identify which part is complementary to which part. If you look into different component parts or machine parts, you will observe these kind of features. I can only say these are planned introduction to make it convenient in assembly time. Have you understood my point?
Yes, sir.
Eliminate fasteners if possible, because extra attachment projected part generally are the cause of accident. So whenever possible, we have to eliminate provision of fasteners. Part should easily indicate orientation for insertion. It is another thing. Whenever we are trying to fit a part into the body, in which orientation it should be placed, that may be a confusion to the user. But if we keep indication in the part, foolproof indication, by which user will be confirmed, yes, this is the orientation in which it is to be fixed, then he can avoid confusion. So indicating regarding orientation of insertion should be there. Main body বা main body te you can keep an arrow, and on the part you can keep an arrow, and if those arrows are aligned, then orientation is matching. You can provide in this manner. Is it understood or not?
Sir, regarding the previous point, sir, what is the meaning of fastener?
Nut, bolt, these are called fasteners, which can fashion two parts.
Oh, okay, sir.
Standardize parts to reduce variety. Suppose during the design, from calculation for 100 different bolts, you can get that one bolt is 15.5, another bolt is 15.7, another is 15.8, in this way. As a designer, you will suggest 16 for every bolt, whether it is 15.2 or 15.8 or 15.6, because it will reduce the variety. If variety is wide, difficult for maintenance, difficult for inventory, difficult for assembly, because in that case 15.6 diameter bolt is to be inserted into a proper place. But if all the bolts are of 16 millimeter, it doesn't matter which bolt you are taking to fix in which position. So minimizing the variety is always advantageous, and by standardization, a designer can minimize the variety, and designer should adopt it. Designer should follow it. Is it clear?
Yes, sir.
So color codes are sometimes introduced for ease of assembly. That when it is red color, when it is white, the green color means this. So by putting color on the part, some information regarding assembly can be conveyed to the user. You can use color code. If it is standardized, that red color means it is to be inserted on the right side, blue color means from the left side, then just by putting the color on the product, you can convey that it is right side, it is used at right side, it is to be used at left side. So by color coding, you can convey some additional information to the user, which can be useful regarding or during assembly. Design the mating features for easy insertion. If you shape the product in such a manner that, like plugging conception, that male-female conception is there, mating feature conception is there, then it will be easy to assemble the different parts. So designer has to consider, if possible, it has to introduce and provide alignment features. It is very important. When two products are integrated, how their alignment? How? Because if both the members have common holes, their axis is to be collinear, and that is to be ensured. This is called confirmation of alignment. So to confirm, to ensure the alignment, some product features should be there. There may be a point on the two parts. During the assembly, user will verify whether these 2 points are coincident after assembly. If they are coincident, then alignment is ensured. So just by confirming the coincidence of 2 points on the two body, user can ensure the alignment of two parts. Designer has to keep points on the parts. This is the conception of designer. This is the responsibility of designer to provide alignment features on the product. So these are the different issues that designer has to consider during designing regarding assembly point of view. Understood?
Yes, sir.
Yes, sir.
Manufacturing aspects. Regarding manufacturing aspect, you should have certain knowledge regarding different manufacturing procedure. What are the related knowledge? First of all the materials are not suitable for any type of manufacturing process. You know that there are different manufacturing processes like casting, machining, forging, welding, etc., etc. A particular material may be suitable for casting, may not be suitable for machining. Designer should know. Because during the design, it is planned that this material will be used, considering the strength, the environment, and other aspects. Now, designer has to suggest what will be the appropriate manufacturing process. Then designer has to know which manufacturing process is suitable for this material. What are the materials suitable for casting? What are the materials suitable for machining? Designer has to know what material property actually is related to the particular manufacturing process. If you consider the casting as a manufacturing process, then what are the important information? That complex cell or complex part are difficult to be manufactured through casting process because it requires integrity in the molds required for the casting. Most of the metal can be melted and therefore can be used for casting. By casting, you cannot produce an item for which the dimension is less than 6 millimeter. It is difficult. So there are certain features which are important to casting manufacturing process. This knowledge designers should have. Regarding machining, another different considerations are there. Different considerations for forging, for welding, different aspects are there. So what are the related questions? What material suitable? What are the effect by the manufacturing process over the component during the manufacturing process? During the machining process, the material property can be changed to certain extent. Residual stress may be there. Designer has to know it, whether he can allow the residual stress in the component due to machining or not. If possible, machining will be accepted. If not, machining should not be accepted. Alternative manufacturing procedure is to be sought out by the design. By forging process, realignment of the fiber within the material, crystalline structure occurs. Whether it is allowable or not, designer should verify. If not, forging is not accepted. If yes, forging can be accepted. So there are a lot of manufacturing aspects which a designer has to consider during the design period. Do you agree?
Yes,
Yes,
sir.
sir.
To know it in detail, you have to know the different manufacturing process, their influence over the material property, their important feature, etc., etc. But you have to know, or rather here you have to appreciate that there are a lot of aspects related to manufacturing process which designer has to consider while designing. This point is to be accepted or not. Do you accept it? Hello?
Yes, sir.
Are you hearing me?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Another important area for consideration is working environment. What is meant by environment? There are several points like temperature. Why temperature is so important? Because it can change the material property. High temperature can invite creep, low temperature can invite brittleness. Both are dangerous from strength point of view. Performance or life both can be affected. So what is the temperature? Designer has to consider it. If high temperature, then some suitable materials are there. For moderate temperature, another material is there. But designer has to consider the effect of temperature on the performance, on the component life, etc. and etc. And what will be the target of the designer regarding environmental aspect? Least possible effect on nature. Because today the nature is gradually becoming vulnerable for human being due to the industrial damage. So least possible damage on the nature is to be considered. Today, one of the important factor by which a product is rated is qualified the carbon rating of the product. Throughout the product life cycle, what amount of carbon is being generated, that will be the feature of the product. Lower the carbon rating, higher the quality of the product to make environment safe. Low energy consumption, it is obvious, low pollution, use of renewable energy, recycle, safe disposal. These are the important issues related to environment that the designer has to consider while designing. Now, important area for the designer, how material is selected. How? What are the different aspects that designer has to consider while selecting a material? 4 points are there. First of all, availability. Whether it is available in a standard product. We generally avoid to develop a new material for a particular product. Attempt should be there to fulfill the purpose of the component, selecting some available material. Cost of the material. Because in a product, cost of the material used, specifically in mechanical item, bears the lot proportion of the total cost. So if we can reduce the cost for material, we can reduce the cost for total product. So cost of material is an important issue. Mechanical properties. What is the relevant mechanical properties of the particular material? Depending on that, designer will select it or reject it. If you find that your application is under fatigue loading, periodic loading, then you have to find a material for which fatigue strength is high. So mechanical property of the material plays an important role whether it will be selected or not for a particular product. And also manufacturing consideration. Ultimately, the product is to be developed through some manufacturing process. A product may be very cheap. The important mechanical property required is there, but very difficult to machine the product, cast the product, forge the product, weld the product. If it is difficult to be manufactured by the available manufacturing procedures, then also sometimes it may not be selected by the designer. So whether the material will be selected or not, that depends on 4 points: availability, cost, mechanical properties, and manufacturing cost. Have you understood so far?
Yes, sir.
Yes, sir.
So, for reference, we have to know certain mechanical properties of the metal. Which mechanical properties of the metals are important, and designer has to consider. First of all, strength. Then you have to know what the material property represents the strength related parameter of a material. Again, it depends on the failure mechanism. Failure may be due to exceeding the plastic limit. Failure may be due to plastic collapse. Failure may be due to fracture. May be due to creep. May be against creep load, impact load. And for different failure mechanism, different parameters are there representing the strength. Suppose in case of plastic collapse, ultimate stress of the material represents the mechanical property. In case of fracture failure, fracture toughness is the material property which gives you the resistance of the material against fracture. Similarly, for impact strength, toughness is the parameter. For creep rupture strength is another material property is there, which actually gives you the relevant material property. So what material property should represent the strength of the material that depends on the failure mechanism considered for the product. Is it clear?
Yes, sir.
Another material property is stiffness. Stiffness is generally represented by the elastic modulus of the material. Stiffness, material property which represents the stiffness is given by the modulus of elasticity. Elastic limit. Elastic limit will give you the material property while plastic deformation is concerned, because elastic limit divides the material property in two zones. Below the elastic limit, the material behavior will be elastic in nature, and beyond the elastic limit, the material behavior will be plastic in nature. So the material property which governs, which decides that whether there will be plastic deformation or not is the value of yield stress, or sometimes it is elastic limit. Elastic limit represents this property. Plasticity. You know, beyond the elastic limit or yield point, material undergoes plastic deformation, and their stress-strain relationship is not linear. Not linear. That nonlinear response of the material can be fitted through different types of nonlinear curve. Here, some polynomial type curve is given, or power law type curve is not polynomial, power law type curve is given, that plastic stress, or in the plastic region, the total stress is given by K into epsilon PL to the power n. Epsilon PL is the plastic strain of the material, and n is a material property, K is a material property. K is called hardening coefficient and n is called hardening exponent. So this plastic response, or rather stress-strain response in the plastic domain, can be fitted, can be characterized by different forms of curve. One of them is given here. Another may be Rambach was good. Sometimes exponential curves are there. But for every such curve, there will be relevant material property. Here material property is hardening coefficient K and exponent n. In other form, other material properties will be used. You can determine this material property by experiment. So what are the material property representing the plasticity of the material? Is it clear to you or not?
Yes, sir.
Ductility is another property. Ductility is the capability of a material to absorb plastic deformation before failure. Before failure. If the amount of plastic deformation is high, the material is more ductile. If it is low, then it is less ductile or brittle. Tensile strain or ultimate stress may be very high, but there are material for which ultimate stress is very high, but ductility is very poor. Very poor. Because this material doesn't allow sufficient plastic deformation before failure. And what is the measure of this ductility? Generally, for simple measurement, we measure the ductility of the material by failure strain, or percentage of elongation, or percentage of reduction in area. Any of these three parameters can be representative of ductility of the material. Is it understood?
Yes, sir.
Malleability. Malleability is it is some kind of reflection of ductility, but not completely controlled by ductility. It's a different property of the material, for a material. Malleability means how thin sheet can be manufactured by rolling or other plastic deformation. To what level of thin sheet material can be deformed without creating any damage? Suppose when in an automobile shop for framing the body, it is worked through sheet metal, and for selecting the material for this sheet metal, malleability is the most important and significant parameter. Brittleness. Brittleness is the counter or reverse of ductility. If a material doesn't allow plastic deformation before failure, then the material is brittle. Toughness. Toughness is the energy absorbed by the load deflection curve up to failure point. And generally we measure this by Charpy or IJOT test. I think you are already exposed to Charpy number, IJOT number. And this number represents the toughness of the material. Generally, test specimen is subjected to some impact kind of loading, and energy required for fracture is measured, and it represents the toughness of the material. Machinability. How easily it can be machined. That is the machinability of the material. Some material can be easily machined in a lathe or a milling machine. Machinability is good. If a material can be forged easily, then forgeability is good. Similarly, weldability, castability, how easily it can be manufactured by a particular manufacturing process is reflected by either machinability, forgeability, weldability, castability, etc. and etc. Have you understood?
Yes, sir.
Resilience is the energy up to elastic limit. It is the energy absorption capacity of the material up to elastic limit. Creep I have already discussed, and for using the creep phenomena in design, we require to measure creep rupture strength or mean strain rate during the creep as material property. These two parameters will be input to the designer if designer has to consider the creep as a failure mechanism. We will discuss regarding creep rupture strength or mean strain rate later on. Fatigue. It is another important area. When a material is subjected to a variable load, repeated load, fluctuating load, it is observed that inside the material there are tiny cracks which starts to grow in every cycle, though the applied load level is below the yield point. Try to visualize. Applied stress level is below the yield point. Even at this lower load, the crack within the material will start to grow in every cycle in case of periodic loading. What will happen? After a huge cycles, the crack growth will be also of large amount. And if the crack growth is of large amount, the load bearing capacity of the cross section will be reduced and material can fail. This kind of failure is called fatigue failure. Fatigue failure. And from experiment, the material property related to fatigue failure are identified. They are called endurance limit, strain life curve, etc. and etc. We will discuss all these in detail later. Hardness is the another material property. Hardness is the resistance of the material against abrasion, scratching, wear. When on the top surface loads are there is a tendency of the material for wear, for generating scratch, and the resistance against this abrasion varies from material to material, and this is quantitatively measured through hardness. And measurement of hardness is also of different techniques. There are different testing procedure for measuring hardness: Rockwell hardness, Brinell hardness, Vickers hardness, source scleroscope. There are different hardness measurement method, and for every hardness measurement method there is a hardness parameter representing the hardness value, right? Brinell hardness number, Rockwell hardness number. This represents the hardness of a material. Another material property is called fracture toughness. When cracks are there inside the material, then failure mechanism of the material follows different type. What happens that depending on the material has a resistance against crack growth. The crack present inside the material may grow, may not grow. How it is determined? If the applied load level is in such a level that it can overcome the resistance of the material against crack growth, crack will start to grow. And if we increase load, this crack growth will be continued. And ultimately, the material can fail. So there are certain material properties which are required to measure the resistance of the material against crack growth, against fracture. Those material property or that material property is called fracture toughness. Higher the fracture toughness, higher the resistance of the material against crack growth. And this fracture toughness for brittle material, it is measured by K1C. For ductile material by delta C or J1C. These are the fracture parameters used for brittle and ductile material. For brittle material, it is K1C, critical stiffness critical stress intensity factor, and for ductile material, it is delta C, CTOD, critical CTOD, or J integral, critical J integral. Wear and tear is another material property. I have already discussed that due to rubbing, due to friction between two parts, there may be material loss, which is called wear. So it will reduce the size of the component because of wear and tear. And reduction in the size will cause reduction in the strength, leading to failure. So knowledge about wear, effects of wear, resistance against wear are to be well understood by the designer. Is it okay so far?
Yes, sir.
Yes, sir.
কারোর কোনো কোয়েরি থাকলে বলো। কোয়েরি আছে কারো?
हाँ सर.
আচ্ছা। Standardization. Another issue that the designer has to follow is standardization. The standardization includes material, dimension, shape of the component, method of testing, method of marking, packing, and storing of the product. Standardizations are possible for material. Materials are standardized. Composition of the materials are standardized. They have been categorized into different groups, but you cannot get material of any composition. Of any composition, it is not available, only under standard composition. So materials are manufactured as standard composition. Dimensions. Different standard parts like bolts, nuts, shafts, etc., etc. Any dimension is not available in the market. Only certain dimensions are available in the market. The variety is to be reduced because variety increases the production cost. Therefore, we have to manage the total demand. Manage the total demand is a continuous spectrum. Somebody can require 15.5, somebody can require 27.8, somebody can require 15.6. But if the manufacturer is to supply 15.5, 15.6, like each member, then he has to produce infinite number of product of dimensions, which is impossible. So he has to take decision. What dimension will be produced? If it is standardized, if it is agreed internationally, then what will happen? Designer will know that there will be no 15.5, only 16s are there. Bolts with even number, bolt of diameter with even number are available. 13 will not be available. 10, 12, 14, 16, etc. will be available. And he has to adopt that. If by calculation design dimension comes 15.7, he will adopt it by 16 because he can then ensure the availability. And standardization is required. It is an important issue because it can reduce the variety, it can reduce the cost, reduce the inventory management. So because of this, standardization is essential. Class achi. Have you understood?
Yes, sir.
Where the standardization is required or done, that material, dimension, shape of the component, method of testing method. Because unless the testing method is standardized, nobody will accept your result. Testing method must be standardized. Method of marking, packing, sorting, storing, etc. are there. In design, you have to face two terms. One is standard, another is code. Code is a different thing. Code is a standard or standardized rule for analysis, design, manufacturing, testing, etc. When it is a code, it is a set of standard rules that you have to follow. And how this code has been generated? Code has been generated through analysis, testing, etc., etc. Suppose boiler code. When you are designing boiler, you have to follow certain standard principles. It is not flexible to the designer. Designer has to follow certain specified principle of design. And this principle has been developed, rather has been standardized through rigorous practice, testing, etc., etc. That is a code. So designer has to follow standard and codes when required. Category of standard may be company standard, national standard, and international standard. Company standards are generally poorest quality of standard. Then national standard, then international standard. Benefit of standardization are huge. It is given here. Reduction in types and dimensions. Sometimes it can ensure the safety. It results in overall cost reduction. Reduction in manufacturing facilities improves quality and reliability. Easy to replace. Interchangeability is also important. Have you understood the benefit of standardization from here?
Yes, sir.
Yes, sir.
Standard for materials, you have to designate the material with rules given by the standard. If it is cast iron, generally FG will be the notation. For steel, some different notation which reflects the composition of the material. Standard for shapes are there, standard for dimensions are there, standard for testing methods are there. You can refer any standard available, and there are standard generating unit or agency like ASME, American Society of Mechanical Engineers. ISI is the national level standard in India, IS, and ISI is the international standard. So there are different standard forming agency, and their rules and specifications are different. British standard may not match with the Indian standard. American standard may not match with the British standard. And compiling all these standards, there remains international standard. তোমরা কি বুঝতে পেরেছো?
স্যার
হ্যাঁ স্যার।
স্যার একটা কোশ্চেন আছে।
বলো।
হ্যাঁ স্যার, বলছি যে মানে কোনো কোনো স্ট্যান্ডার্ডাইজেশনের ক্ষেত্রে মানে স্ট্রেনটাকে কম্প্রোমাইজ করতে হয় না, মানে কোনো কোনো ক্ষেত্রে ধরুন যে মানে আমার এরকম হচ্ছে যে একটা মেশিন বানাচ্ছে আমি, সেক্ষেত্রে মানে 16 আর 18 এরকমটা এবার স্ট্যান্ডার্ড বোল্টের ডায়ামিটার অ্যাভেলেবেল আছে, তো সেক্ষেত্রে আমি যেটা বানালাম সেক্ষেত্রে 17 সেন্টিমিটারের যে মানে ওই ডাইমেনশনের মানে নাটটা আমার সিস্টেমটার ক্ষেত্রে একদম পারফেক্ট, মানে সেটা সবচেয়ে বেশি ওই সিস্টেমটাকে স্ট্রেংথেন করছে, মানে স্টেবিলাইজ করছে, তো সেক্ষেত্রে আমরা কি করব?
আমি আগে যদি বেনিফিট অফ স্ট্যান্ডার্ডাইজেশনটাকে অ্যাকসেপ্ট করে নিই, 17 হলে অ্যাকিউরেট হতো, আমি 17 না নিয়ে 18 নেব। স্ট্রেংথটাকে কখনোই কমিয়ে স্ট্যান্ডার্ডাইজেশনকে নেব না, স্ট্রেংথটাকে দরকার হলে একটু বাড়ানো থাকবে স্ট্যান্ডার্ডাইজেশন করবার সময়। আমার তো 17 এলে 16 নেবারও স্কোপ আছে, 18 নেবারও স্কোপ আছে। আমি 16 নেব না, 18ই নেব।
ওকে স্যার।
Preferred number is another issue. For standardization, we require to produce item of discrete manner, not continuous manner. Not all the dimensions will be manufactured. Hello? আমি একটু ক্লাসে আছি। হ্যাঁ। So here, preferred number was introduced by some French scientist, Renard, and it was suggested that we can use the different geometric series, member of different geometric series, and the common ratio of that different geometric series will be taken as 10 to the power different value, like 10 to the power 1 by 5, 10 to the power 1 by 10. Suppose fifth root of 10 is the value 1.58. So a series, geometric series with common ratio as 1.58 will give you a series, and different members of that series should be the dimension which will be accepted for standardization. Similarly, another series where common ratio will be 10th root of 10 means 1.26. Another series 1.12. If the common ratio is 10 to the power 1 by 5, then the name of the series is R5. R comes from the name of Renard. R10 is the series where common ratio is 1.26. R20 is the series where common ratio is 1.12. In this way, R80, where the ratio is 1.03. Higher the number is the series, then finer the differences. There should be a starting value in the series, suppose 10 millimeter. Then after 10 millimeter, 10 into 1.58, that means 15.8. And if we just round off, then the number will be 16. So 10, 16, in this way, the member of the series will come in the R5 series. But if it was R10 series, then 10 into 1.26, that means 12.6, that means 13, 10, 13, in this way, the series will come. And these numbers are called preferred numbers. Have you understood how preferred numbers will give you the series for standardization?
Yes, sir.
মানে স্যার আমি কোন ক্ষেত্রে R5 নেব আর কোন ক্ষেত্রে R10 নেব সেটা কোন বেসিসে ঠিক হবে?
এটা হচ্ছে যদি আমার অ্যাভেলেবিলিটি কোর্স সিরিজ তৈরি করতে যায়, রিকোয়ারমেন্টের ফ্রিকোয়েন্সি স্টাডি করা হয়, রিকোয়ারমেন্টের ফ্রিকোয়েন্সি স্টাডি করে সেই স্পেকট্রাম থেকে দেখে নেওয়া হয় যে মিনিমাম গ্যাপ কতটুকু ভ্যারিয়েশনে লাগছে, তার উপর ঠিক করে সিরিজগুলোকে সিলেক্ট করে, মার্কেট স্টাডি করে, রিকোয়ারমেন্ট স্টাডি করে, সার্ভে করে।
ওকে স্যার।
এর প্রেফার্ড নাম্বার বুঝতে পেরেছো তো?
স্যার বলছি মানে ওখানে যে সিরিজটা ছিল আগে, মানে আমরা দেখছি যখন ডাইমেনশন যখন কম স্যার তখন মানে গ্যাপটাও কম হচ্ছে, কিন্তু যখন ডাইমেনশন বেড়ে যাচ্ছে তাদের মধ্যে গ্যাপটাও বাড়ছে। তাহলে যদি আমি বড় ডাইমেনশনের কোনো কিছু ডিজাইন করি, এই দুটোর মাঝে যদি কিছু আছে, তাহলে তো স্যার আমাকে পরেরটা নিতে গেলে অনেক গ্যাপটা বেড়ে যাচ্ছে। সেটা তো মানে ডিজাইনিং এর ক্ষেত্রে একটা অসুবিধা।
না, আমি R5 সিরিজ থেকেও সিলেক্ট করতে পারি, R80 থেকেও করতে পারি। R80 অনেক ফাইনার সিরিজ, অনেক হিউজ নাম্বার অ্যাভেলেবেল, তাই না? ধরো 10 আর 100 এর মাঝখানে যদি R80 সিরিজ ইউজ করি, তাতে অনেক মেম্বার পাবো, ফাইনার গ্যাপে পাবো। প্রশ্নটা হচ্ছে যে আমরা সাধারণত এই ফর্মুলাটা দিয়ে সিরিজের মেম্বার গুলোকে আইডেন্টিফাই করার চেষ্টা করি। R5 হলে 10 টু দি পাওয়ার 1/5, মানে 1.58 দিয়ে মাল্টিপ্লাই হতে হতে যাবে, আর 80 হলে 1.03 দিয়ে হতে হতে যাবে। এবার 1.03 বা R80 সিরিজে অনেক ফাইন সিরিজ, অনেক ক্লোজ মেম্বার গুলোকে পাবো, R5 এ একটু ওয়াইড গ্যাপ। এবার ওইটা একটা রিলেভেন্ট কোয়েশ্চেন যে কোন প্রোডাক্টের ক্ষেত্রে কোন সিরিজ নেব। একই প্রোডাক্টের ক্ষেত্রে দু রকম সিরিজও থাকতে পারে, তিন রকম সিরিজও থাকতে পারে, এটা খানিকটা মার্কেট সার্ভে করে ডিপেন্ড বার করবে। কিন্তু এই রুলটা ফলো করলে কি হবে, অন্যরা জানতে পারবে যে কোন কোনগুলো অ্যাভেলেবল।
আমার এটা অর্গানাইজড ওয়েতে থাকবে।
হ্যাঁ, এন্ড অর্গানাইজড ডিসিশন থাকবে। আজ এই অবধি থাক নাকি? অবশ্য দুটো স্লাইড আছে না? হ্যাঁ বলো
স্যার
একবার কমপ্লিট করে দিন স্যার।
আগের
দুটো স্লাইড আছে।
না, আমি করে দিচ্ছি, আর 3-4টে আছে।
স্যার
বলো,
আগের
কি প্রশ্ন?
স্লাইডে ওই প্রেফার্ড নাম্বারসে মানে ওইগুলো কি কেন রেশিও হিসেবে চুজ করা হয়েছে 10 টু দি পাওয়ার 1/5, 10 টু দি পাওয়ার 1/10?
মানে এই কেন 10 টু দি পাওয়ার 1/5 এ গেল?
হ্যাঁ, মানে এরকম নাম্বার কেন গেল?
এইটা আমি একটু জেনে বলবো গো, আমি এটা এক্স্যাক্টলি কখনো ভেরিফাই করিনি। প্রথমত এটা রেনার্ড একজন ইঞ্জিনিয়ার এটা সাজেস্ট করেছিল, সম্ভবত আমার ধারণা এই রেশিওতে মেনটেন করলে মানে এটা আমি না জেনে বলবো না, আমাকে আর একটু দেখে বলতে হবে, একটু দেখে বলার চেষ্টা করবো যে ঠিক এক্স্যাক্টলি এই নাম্বারগুলো নেওয়ার পেছনে কোনো এক্সট্রা বেনিফিট বা রিজন আছে কিনা। I will try to explain you next day, okay?
Okay, sir.
Safety is another aspect to be considered by the designer. It is very important aspect. I think you appreciate it. And safety, while considering the safety, why safety is required? Because there are uncertainty. Designer have designed confirming that it will not fail. But it does not mean it will never fail. Why? Because uncertainty is there. Uncertainty regarding load. Designer specified that the applied load should not exceed that value, but it is difficult to. Hello. আমি আর 5 মিনিট বাদে বলছি, আমি একটা ক্লাস নিচ্ছি 5 মিনিট। There is uncertainty in the applied load. There is uncertainty in the material property. You have prescribed that this material can sustain this amount of stress by testing. But that testing result may not be 100% accurate. There may be error. The material that you have tested and the material that you are going to use in your component may not be similar. So there are uncertainty in the material property. While designing, you have calculated the stress using some strength of material formula, which is not exactly correct, which is approximate. During the modeling, you have simplified the material model. So method of analysis contains uncertainty. Uncertainty due to environment, temperature, toxicity. And also in course of time, material property can be degraded. So as there are a lot of uncertainties, there should be some safety margin to be used by the designer to ensure the safety. Isn't it?
Yes, sir.
Yes, sir.
And safety of the product is introduced by introducing a factor named factor of safety into design. Factor of safety into design. What is the factor of safety? Factor of safety means that by your material testing, analysis, every scientific approach, you can identify, you can evaluate that the maximum load of the member or maximum applicable load of the member is 1000 kg. But actual application of the load should be below that to ensure the safety, isn't it?
Yes, sir.
Now, degree of safety can be quantified by factor of safety. If somebody specifies that though the material can sustain 1000 kg load from analysis, but it will allow only 700 kg. So what is the margin of safety? 1000 by 700, 1.3 or something like that. Is it?
Yes, sir.
Yes, sir.
But while designing, the designer used the factor of safety in a reverse way. How? He used factor of safety as a factor that by testing your material shows that your yield limit is 600 MPa. But designer consciously used a value of 400 MPa as allowable stress into the material. And based on that, he will design. This 400 MPa is the allowable stress. Though the material testing finds or recommends that yielding will occur at 600 MPa. But to keep a margin, to tackle, to cater, to fight against uncertainty, designer will not allow the material to be stressed up to 600 MPa. He will restrict the internal stress by proper design. and to what value, up to what value you will restrict. That value is known as allowable stress. And now the question, how this allowable stress will be determined? Because designer use allowable stress in the strength of material formula. But how this allowable stress will be determined? Allowable stress will be determined by dividing the material property by a factor. Here material property is yield stress. We have to divide the yield stress by a factor K. That factor K is factor of safety. Suppose we choose that we should use a factor of safety of 2. Then we have to divide 600 MPa by 2. We will get 300. Now we will say allowable stress for this material in this case of design is 300 MPa, and designer has to use 300 MPa as allowable stress, and accordingly he has to design. So rather the reverse thing, first you decide what will be your factor of safety. Then you divide the material property by the factor of safety, get the allowable stress. So factor of safety will determine the margin of safety. Is it understood?
Yes, sir.
Yes, sir.
Here I have given the same example I have just told now. Now the important point, what are the factors which determines the value of factor of safety? Here I have listed load. Why load? Because uncertainty is more in case of fatigue, impact, dynamic, static in this order. If the load is static, uncertainty is less. If the load is dynamic, more uncertainty. For impact, furthermore. For fatigue, furthermore. So the value of factor of safety should be highest in case of fatigue, then impact, then dynamic, then static. In case of temperature, high temperature is of low risk zone. In low temperature, material got brittle. Therefore, if temperature is low, higher factor of safety should be taken. For ductile material, huge plastic deformation occurs before failure. You can get some precautions, some hints. You can take measure. So ductile material will not produce catastrophic failure. Brittle material will do that. So you should use higher factor of safety if the material is brittle in nature. Do you agree or not?
Yes, sir.
Yes, sir.
Similarly, test quality. If you follow well standard test quality for the material, you can manage with a lower factor of safety. But if you have a lot of uncertainty in your test procedure, then you have to manage by a higher factor of safety. Manufacturing process. Factor of safety, because material property can be degraded by different manufacturing process to different level. Higher the level, higher the factor of safety. Do you agree?
Yes, sir.
Environment. If it is under saline environment, toxic environment, corrosive environment, which can cause degradation in the material, and protection against those environment can be sometimes managed by using higher factor of safety. Accuracy in analysis. If you get the stress value, calculated stress value using some analytic model or some FE model, FE model may give you, if the model is corrected, FE model may give you a better result, more accurate result. In that case, you can reduce the factor of safety. If your analysis is not accurate, if you have doubt, uncertainty, they are higher factor of safety. Last of all, two factors. Degree of safety. Suppose a cable is designed, one to be used for material handling and another to be used for lift. All other aspects remaining same. For which cable you should use higher factor of safety?
So in the case of lift.
Because here human life is involved. So degree of safety will be determined by the particular application. will ultimately know increasing the factor of safety will increase the dimension of the product, will increase the cost of the product, which is not easily acceptable. So just unidirectionally you cannot increase the higher factor of safety because it will enhance the cost. Therefore, a judicious factor of safety is required. And designer has to know what are the particular features present here and what should be the appropriate factor of safety. This is the challenge to the designer, where he has to apply knowledge, analytic power, awareness, everything. So I have tried to explain you all these design considerations in detail. Have you understood?
Yes, sir.
Yes, sir.
প্রত্যেকে বুঝেছো?
Yes, sir.
হ্যাঁ স্যার।
কারোর কোনো কোয়েরি আছে? Do you have any query, any question?
বলতে পারেন মেশিনেবিলিটি বা কাস্টেবিলিটি একটা পার্ট ছিল, মানে ওগুলো স্যার মানে মেজার করে কি করে যে এটার এতটা মেশিনেবিলিটি?
Feasibility, castability, quantitatively measure করার খুব প্রসিডিওর আছে এমনটা না, but there are lot of aspects of material property which can give you the hints whether measurability or castability will be more or not. Because during casting procedure, what material properties are favored, that those are noted. Suppose fluidity of the metal, sinkage, how volume sinkage will be there. Higher the volume contraction rate, it is low castability. Because then there will be reduction in the size compared to mold. If fluidity is low, it is not preferred for casting because material or liquid or metal in the liquid form should flow into the intricate detail of the molds. So fluidity of a metal governs whether it is good for casting or not. Similarly, by judging different material property which are relevant to a particular manufacturing process, goodness or fitness of that metal regarding that manufacturing process can be estimated, can be assessed. So quantified আছে বলে আমি জানা নেই।
ওকে স্যার।
তাহলে আজকে ছেড়ে দিই। হ্যালো।
Yes, sir.